Hello, good day, gentlemen. So, this is a recording of our continued lecture from statical stability. And this is now calculating the residual area. So, this is for the International Grain Code. So, where we load grain. So, guys, pag naglo-load tayo ng grain, there is a special regulation because of the loose type of cargo. So, ito yung kargamento na nag-loose o tumatakbo pero solid siya. So, ito yung mga grain, mga bigas, mais, and similar like that. Okay? So, pag tumagilid yung barko, ay tumatakbo rin siya. So, merong specific na regulation, that is the International Grain Code for this type of cargo. Okay, so the purpose of this lecture is for us to understand if or to find out if our grain loading calculation have already passed or will pass the IMO criteria for the grain loading. Okay, so meron siyang criteria, particularly the GM should not be less than 0.3 meters. And also we have the residual area criteria, which should not be less than 0.075 meter radian. So this is the criteria, gentlemen, and we will find out, and as we continue we will find out if our cargo calculation or cargo loading has passed the IMO criteria for grain loading or for grain cargo. Okay, so we have just finished the angle of hill, which is from the GC curve 6 degrees. That was round up to 6 degrees in this instance. Okay, up to 40 degrees, which is the angle of curve from 6 degrees. That must be first calculated. Now, in this 40 degrees upper limit, the curve or the plotting angle is assumed to be more than the 40 degrees angle of hill, and because of that we will use the Simpson's rule multiplier 14241 to find out the area under 40 degrees angle of least or hill, and we will subtract that with the area under the trapezium, which we will find out later. Okay, so that is the residual area, and the residual area should not be less than 0.075 according to the International Grain Code of IMO for the criteria for our vessel to pass. And also the GM should be not less than 0.3 meters, which is higher than the normal IMO criteria for other type of cargo, which is only half, which is 0.15 meters GM. Okay, so let us continue for the calculation of the residual area to verify compliance with the code. Okay, so here is the statical stability curve, which we have already calculated. Okay, alright, so We have 6 degrees estimated. That will be to the nearest whole degree. That is for the 6 degrees. Okay, it was calculated based from the loss of GC at 40 degrees angle, and that is 0.102 meters GC, and intersecting with the curve, and that points us closer to the 6 degrees round off. Okay, so that is how we found out the 6 degrees. Okay, so we have to get the area under the 40 degrees angle, and that is based from the 6 degrees angle of heel. So the area will be covering from 6 degrees up to 40 degrees. So the interval will be always be divided into 4. Okay, to use the formula, or to use the Simpson's rule of 143 14241. Okay, 14241. So it must have 4 intervals, 4 common intervals, and 5 ordinates. Okay, so this will be the interval 1, 2, 3, 4 from 6 degrees ordinates, and we have other 4 ordinates up to 40 degrees. So once we divide it, or we subtract first the 40 degrees minus 6 degrees, we will have 34 degrees. Okay, again 40 degrees minus 6 degrees, we will have 36 degrees. Divide it by 4, and that will be, okay, 40 degrees angle minus the 6 degrees angle of heel, that will be 34 degrees. Divide it by 4, which is a fixed common interval, division of the common interval, which is 4 intervals, will be 8.5. So, or 8.5, 8.5. So we will add this to the 6. So the first one is 6 degrees. Okay, plus 6. Okay, that will be 14.5 degrees. Okay, plus interval of 8.5 equals the 23 degrees. Okay, plus 8.5 common interval, 31.5 degrees, and the dash value is 40, which was already calculated using the Kn value given. Okay, so that is how we get the reading. Okay, so that is the curve and intersecting. Okay, intersecting the curve that was already created from the previous calculation, and we have here the equivalent. For 6 degrees, we have 0.120, which was already the 6 degrees was from the original 0.102, which was round off to 6 degrees, equivalent now to 0.120. And then we have the 14.5 degrees angle is now 0.32 intersecting the curve, and then the 23 degrees angle is 0.55 GC from the curve, and the 31.5 is 0.75 GC from the curve, and the 40 degrees is already based from the last calculation, given Kn value is 0.86. So with that information, we can now calculate the area under the GC curve from 6 degrees to 40. So 6 degrees, 0.12, 0, 14.5, 0.32, 23 degrees, angle is heel degrees, angle of heel is 0.55, and then we have 31.5, the GC is equivalent to 0.75, and the 40 degrees is the 0.86 from the original GC curve. Okay, and we have the Simpson multiplier of 14241, and multiply that, we have the product, 0.12 times 1 is 0.12, and so on. And then we will have the sum of the product, which is 6.35 degrees here, 6.35 degrees. Okay, and then we can now calculate the area under the GC curve from 6 degrees to 40 using the Simpson's rule. Area is equal to 1 over 3 times the h, which is the common interval, and that was 8.5 meters common interval, and multiplied by the sum, which is 6.35 over 57.3 is a fixed value to convert the degrees to radian. So 1 degree is equal to, or 1 radian is equal to 57.3 degrees. Okay, so having calculated this one, 1 over 3 times 8.5 times 6.35, you check with your, okay, let us check with our calculator. Okay, 1 over 3 times 8.5 times 6.35 divided by 57.3 equals 0.314, round off to 3 decimal places, meter radian. Okay, so this is the area under the 40 degrees angle of heel. And then we can now calculate, next calculation is the area under the trapezium, which will be subtracted from the area under 40 degrees. Okay, to get the area under trapezium, guys, so it is calculated from the area under trapezium, calculated from the trapezium rule. A, that is the one side, plus B, the other side of the area. Okay, and of divided by 2 multiplied by the base. Okay, so as you can see here, this is the trapezium area. From A is the GC angle. The angle here is the GC based from the angle of heel from the curve of 6 degrees. That is the first side of the area, and the last side of the area is 40 degrees, which is the loss of GC under 40 degrees is 0.102, which was calculated earlier, and that was 0.102. Okay, which was a little lower than 0.120, which is the angle of heel that was calculated round up to the nearest whole degree by the given loss of GC 40 degrees. That was 0.102. So we have already the 6 degrees equivalent of the A, the side of the A and side of the B here, which is 40 degrees. Divide by 2 multiplied by the base. The base is the distance in angle from 6 degrees to 40 degrees. So that will be 40 minus 6, and that will be 34 degrees, guys. So this is the trapezium area, and that is the area under the trapezium, okay, of concern. Okay, and this is now the formula. Okay, That was the given. And now the formula, area under trapezium given is the GC of angle of heel, that is the A, plus the healing arm, which is by loss of GC by 40 degrees angle, divided by 2. The sum will be divided by 2, then multiplied by the base, which is 40 minus 6, that is 34 degrees, and convert to radian is we divide it by 57.3 degrees per 1 radian. And this is now the calculation, guys. Okay, so to get the residual area, we need to get the area under 40 degrees. Okay, and minus the area under trapezium. So we have already the area under 40 degrees, which was calculated earlier, 0.314 meter radian, and we need now the area under trapezium. So to calculate the area under trapezium is we have 0.120, the 60 GC, given by the 6 degrees angle of heel, plus the loss of GC at 40 degrees, and that is 0.102. Okay, equals divided by 2 equals multiplied by 34 degrees, that is the base, from 6 degrees to 40 degrees. So multiplied by 34 equals, and we have to convert this to radian, meter radian, because this is in degrees, so divide it by 57.3 degrees per radian. Okay, and the answer of, I think we missed something. Okay, I will repeat. 0.120 plus 0.102 equals, okay, divided by 2 equals 0.111 multiplied by 34 equals 3.774 divided by 57.3 equals, okay, so may napindot tayong mali kanina. So the answer in 3 decimal places is 0.0658, or in 3 decimal places is 0.066 meter radian. So there you have, guys. May memory plus natin to. Okay, and then we need to subtract it to the area under 40 degrees, loss of GC under 40 degrees, which is 0. Okay, i-clear muna natin. 0.314 minus the 0.066 equals 0.248, 3 decimal places, meter radian. So the IGC, International Grain Code criteria, should not less than 0.075 meter radian. So we pass the residual area, and the effective GM that was calculated earlier is 1.073 meters. The ICG criteria is not less than 0.3 meters. So in conclusion, guys, the ship's loaded condition complies with the minimum intact stability of the International Grain Code. Okay, so that completes our grain calculation, loading grain to determine if it passed the IMO criteria for the grain code calculation. Okay, so you will have a recitation and assignment combined, which is total of 40 points or 20 points each. Recitation and assignment 1 for the final. Okay, guys, and you look at the recitation, and you can do it in your own time or within the time of the classroom. Thank you very much, and have a good day, gentlemen.